would only be setting ourselves up for failure if we were to send all 500 jobs out onto the shop floor to say, go ahead and run whatever you're going to run. Go in. And that is where we kind of, depending upon what we're running, we may have to loop in engineering to understand what the optimization of that testing process is.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at independent ERP and digital transformation consulting firm Elevate IQ. If you got any materials on your shop floor, you might have nesting software to reduce waste. But the admin efforts increased by a standalone nesting software might eliminate the benefits of reducing waste. Also, if you have multiple software on a shop floor, such as MES, QMS, EAM, nesting, SPC, etc., it might be harder to create the roles and responsibilities of different systems with a clear source of authority. This is especially harder due to the amount of back and forth churn involved for each job order with these integration flows. So what are the best practices for incorporating nesting processes and software into your shop floor? In today's episode, we invited a panel of cross-functional experts for a live interview on LinkedIn who brings significant expertise to discuss nesting best practices. We discussed what nesting process is and which industries are likely to use it as part of their production process. Finally, we discussed the pros and cons of integration architecture around the nesting process and the place for nesting software in the integration architecture. With that, let's get to the conversation. Hello everyone, welcome to today's show. And if you're joining for the first time, this is part of our digital transformation series, for which we meet every Thursday at 5:30 p.m. Eastern. We pick one topic related to digital transformation space, and we always have an expert panel here. So for today, we are going to be discussing a very deep and niche topic, but it's very interesting the way it works. It's going to be super helpful for manufacturers, obviously, because of the value that it brings to the table. So we are going to have a lot of fun discussing that. Before we do that, we are going to start with everybody's intros. I am going to start with my intro. If you don't know me, I am Sam Gupta, principal at Elevate IQ. Elevate IQ is the independent ERP and digital transformation consulting firm. And nesting is always a very interesting sort of outlier in the ERP engagement, so it's always fun. On that note, I am going to move to Chris for his intro.
Hi, thanks, Sam. I'm Chris Gardini, the owner and CEO of Turnkey Technologies. We're a 28-year Microsoft Dynamics ERP implementation partner. So we've come across nesting. It's really start talking about smart factory concepts, so looking forward to the discussion.
Okay, amazing. Thank you so much for being here, Chris. Dave Dozer, and today also we have Dave Problem. So Dave Dozer, can I ask you to introduce yourself next?
Absolutely. We seem to do this all the time anymore, Sam. Got to coordinate these better.
Yep.
Dave Dozer, the president at Blaze IT. We're a implementer and reseller of cloud ERP solutions, specifically in the manufacturing space. Very excited about this topic today. It's definitely one a lot of times is a little disconnected from the ERP. Had a chance to work with it a lot in the past as well. So really looking forward to the discussion today.
Okay, amazing. Thank you so much for being here, Dave. Dave Griffith, can I ask you to introduce yourself next?
Absolutely. So, Sam, I'm actually excited for the all Dave show when there are just 5 Daves talking, and then it gets really confusing for everyone. But for everyone that doesn't know me, my name is Dave Griffith. I run a company called Kaplan Solutions, and we focus on sensible digital transformation. And my background, our experience is much more on the shop floor portion of it. So how do we connect the machines and then push the information up? And I am generally working hand in hand with the folks like you see here on this panel to try to figure out the right and best way to get that done. Looking forward to having this conversation, Sam.
Okay, amazing. Thank you so much for being here, Dave. Andy, can I ask you to introduce yourself next?
Yeah, my name's Dave Griffiths. So there's three Daves on the call now. Will the real Dave please stand up? No, my name's Andy Pratico. And I'm with, I've been working with ERP software for manufacturers, small to mid-sized manufacturers for about over 40 years. I've worked all over the U.S., all over Canada. I've worked with over 1,000 manufacturers, and I've published a book on how to evaluate and select ERP software, which is on Amazon. So thank you for inviting me, Sam.
Thank you so much, Dave Griffith. The real Dave Griffith, I guess. Okay. All right. Thank you so much, guys. And if you're in the audience and joining for the first time, make sure you guys post your questions and comments. We typically try to cover them during the show. If we run out of time, then we'll make sure that you guys are going to receive your answers. On that note, I am going to start with the first question with Chris. So, Chris, do you want to set the stage about nesting? What is nesting and which industries are going to be using, this whole nesting process?
Sure. We used to do nesting back in the 80s in computer science classes. We'd write a loop, right? And they said nesting.
Yeah.
It's not the same thing. And so as you look at nesting, and everybody's like, what is it? It's not birds, but in fabrication is one example. And I probably don't know all of them, but in laser cutting, thermal cutting. And I was lucky enough to go to the Fabricam Expo, and they have humongous machines that are laser cutters. And they're running sheets through there. And what nesting essentially is how do you take these sheets of metal, different thicknesses, types, etc., and take the stream of jobs, demand, right? All this stuff that needs to be cut, figure out how to place it on these sheets and fly it through the system. And whoop, the little birds are cutting over there and the squares and rectangles, but it could be all types of shapes. And as you get into the complexities, now you're thinking about, okay, where's the smarts that figures out how to do that and takes all these streams of data? So a lot of data. And again, it's an algorithm that places these objects, these jobs, on a sheet, cuts them. Okay, great. So that sounds easy. Well, it's not. There's a lot of intelligence around that. And that's one concept of nesting, but it's really, they do it block style, which is not as efficient, or they do it where it's really optimizing all the shapes and really fitting them in. And, one problem is the machine's deciding. We got AI over there now. So artificial intelligence is optimizing and really trying to drive up that. So then the other part of this is data. What do I do with all the data? How do I know cost? Okay, how much is the machine? Let's say it's $1 million. Well, how many jobs a year? How many minutes a year? Now I'm trying to figure out, how do I pay for that thing? One aspect, right? Costing this machine. So there's data by job, by piece, by time, by worker standing there, or two workers, who knows? You hear me mention a lot of data points, and this is all around this big, humongous machine we bought for $1 million, and we're all watching it shoot things out the other end. So processes, right? What do I do with that data? What if I can't accept it automatically or, programmatically? And we talked about machine time, pieces, good, bad, scrap. How big was the sheet? Did we allocate all the costs? Is there a ratio calculated based on the density of a job on a sheet? Perhaps there's a lot of algorithms behind that, but there's clocking time. Again, all this data. We have a traditional ERP. These are advanced features in manufacturing where we're building out a BOM and a routing and operations in machine time, and we normally guess, right? Oh, it's going to take 13 milliseconds per piece. Who knows, right? You're randomly allocating machine time. And rarely are people out there collecting it precisely. So now here we are, jump forward, it's 2022. We have an opportunity. The equipment manufacturers have innovated on their side. There's even IoT, right, where the machine says, hey, I need service. Remember, that's going on too. Not just sending data streams but receiving data, but again, a lot of integration work that still doesn't exist today. So, but again, on the ERP side, to do that today, it's all manual, right? We're recording machine time on this job, on this operation. Maybe the operator clocks in and clocks out and automates part of that process. How many pieces when he clocks out? So we can capture that, but the automatic feeds are, again, that evolution. And we say smart factory, and it's, because now, I have amazing data real quick. What's working well? What's working bad? Where's the bottleneck? Which machine's down? What do I do? So the decisions, and now, again, we can go on and on, Sam. So that's a good start.
Okay, so very interesting insights there. And obviously, when we are thinking about nesting, sheet metal is one of the industry which probably is going to be, everybody is going to be speaking about that. Number one, because of the cost pressure that sheet metal industry at this point of time is experiencing in general, that is going to be slightly more commoditized manufacturing. And they are really looking for the efficiencies in the manufacturing process, whether you talk about saving materials or you talk about just increasing your profit margins. But, have you seen, Chris, in any other industry where the nesting process is being used? Or is it primarily really in the sheet metal industry?
I think it's in that industry where they're cutting pieces and trinkets out of flat steel and sheets. Absolutely. Thermal cutters, laser cutters. That's the equipment I see most using nesting because the CNC not applicable. A lot of pieces of equipment or work centers, you could say they're not applicable to that, where they can run concurrent or they can stamp out 3 jobs at a time or 16 jobs at a time. That's where you get into this concurrent production, which is a little different. Maybe injection molding could think about algorithms on that, but they're still manufacturing molds, and so a little different than a dynamic laser algorithm where you're not making any molds. It's just cutting completely autonomously.
Okay, amazing insights there. Thank you so much, Chris, for that. Dave Dozer, so now I'm actually coming to you, and I don't know when you mentioned that you have done some work in the nesting space, and I don't know if you have done more in the sheet metal space or any other industries. Do you want to talk about your experience in terms of where they were using the nesting process in their industry?
Yeah, absolutely. So probably, 10 plus years ago, I always hate dating myself, but, I've been around for a little while now. Had the opportunity to work with a tier 2 auto manufacturer, and we actually produced like the headrest and seat backs and some of the arms for some various auto manufacturers. So we're doing a lot of cutting around a lot of times leather or fabric, and it would be on a big giant roll, essentially. So if you think about that, and you've got a left side and a right side, maybe different shapes of material that ultimately was going to be sewn together into one final unit. And a lot of times too, you've got like a left side and a right side, and then it's okay. Well, how are we going to fit this together? And now there's a void in the middle there. So how can you fit in from these other jobs that may or may not necessarily be related to that particular order or to that particular job? How can you kind of fit in these small pieces? Now, again, this was over 10 years ago, and honestly, we were not super technologically advanced in that space. So there was literally, an engineer that would sit down with the software application independent from the ERP and say, okay, I'm going to take these jobs. They all use the same material, and I'm going to sit down and visually, on the application, map out how all these pieces can go together to optimize the yield from, in that case, a big piece of leather, perhaps. So that even today is still kind of a big challenge when we're talking about nesting, is that relationship between the real world and what's actually going to happen, and back to the ERP, because whether it's leather or sheets of steel or sheets of plastic, there's kind of a disconnect there because the ERP, in a lot of cases, isn't smart enough to know what shape something necessarily needs to be. It knows, how much you need, how long it's going to take to process it, but it has no idea that it's curved or it needs to be cut in this particular direction. So that's a lot of times where you see, I don't want to say falling down, but where you see either another software application or a human having to intervene to align what the bill of material says and the production orders say on the ERP side to what's really going to happen, out there in real life.
Okay, so some very interesting insights there. And I don't know, I personally was not thinking that, this could be applicable in the leather or in those industries. And I can see the application, the way your metal industry is going to work. If you need to have cuts, and leather could be very expensive.
Right.
And then you are literally looking at, saving each and every piece that you can probably save in your manufacturing process. So I can see a lot of value there. Now, the comment or the follow-up that I am going to bring is going to be what Chris had mentioned. So obviously now we are looking at many different technologies, systems. Everybody's sort of trying to do everything. Okay.
Right.
That's how most technologies are. And they are saying, you know what, smart manufacturing, I am going to bring all of this data. I am going to bring my human inputs. I am going to bring the inputs related to the person who might be standing in front of the machine. And then I am going to optimize your nesting process. Now, let's think about this for a second. Because when you are thinking about optimizing cuts themselves, that itself is a very difficult process.
Mm-hmm.
You are going to be increasing a lot more variables, especially your internal variables. To your example, when you mentioned that when you are looking at optimizing it based on your internal understanding, but when you are going to be taking it to the real world, it doesn't match.
Right, and that happens a lot, especially when you get very specific and very detailed there, and then all of a sudden it doesn't quite line up quite right. It's one thing doing it in the software side or the software world, and then translating that into the real world. So it's a very complex process, and frankly, it's one of those things too. You'd be surprised, or at least from my personal experience, how many manufacturers that are $100 million plus type of companies that are still doing this in a very manual and human intensive type of way, just because it's one thing to talk all this technology, but then to apply it in the real world, this is one of the most difficult areas to, I think at least, to get aligned with the ERP system.
Yeah, could not agree more. Thank you so much, Dave, for that. Dave Griffith, so I am coming to you, and obviously we are going to be testing the knowledge of these guys in terms of manufacturing, because obviously you live on the shop floor, right? So I don't know whether you agree with whatever we have spoken so far in terms of whether this is going to be really applicable for the metal and stamping sort of settings, as well as leather is one example that he mentioned. Where else have you seen nesting? What has been your experience, Dave?
Yeah, I think that all of these are great examples, Sam. I would say, in my experience, when we look and get closer to commodities, right? So the closer and closer it gets to I'm making my margin based upon how little scrap I have, right? So when scrap becomes a higher and higher percentage of the money that you don't make, right? I'd say that becomes big. So I've seen kind of a number of options. I would say almost anything that's cutting, right? So if we've got a finite amount of material, I think sheet metal is a great example. I think leather is a great example. I would say any sort of fabric, because we get fabric and rolls, we get paper and rolls. I've seen like extrusion opportunities where we've got a finite number of extrusion, call it 10 meters. And our goal has to be, how can we get the parts that we need out of it with the smallest amount of waste? I know extrusion in and of itself they're running very high efficiency percentages, and 1-2% is huge for the bottom line of those organizations. So I think kind of any of those are really good. I'd actually like to give kind of a couple of examples. So I think Chris and Dave gave great examples. I'd like to kind of give from the as good as it gets to the as bad as it gets in my experience over the last couple of weeks, right? So like, let's say as good as it gets, Chris is working with a company that does sheet metal, right? We've tied all of our machines into the shop floor. We've built in MES. We take all of that data, we pump it up, including scheduling, into the ERP system, and either the ERP or some other system can go and tell us the exact template of what we're going to cut tomorrow and probably for the next 5 days, based upon the actual orders that we have and the demand that we need to fill, right? So I would say that is the best one can possibly do. And then all of that gets piped down at some point before we're actually going through the process of cutting the sheet metal. On the other side, I have friends who work with companies that let's say that they have a number of similar processes, and one of their outcomes is screen doors, right? And so they've got these screen doors, so they've got some stamping, they've got we cut screens and everything else, and they have no idea. The foreman has no idea what they're going to run when he shows up in the morning, right? So he has to show up and get 2 different spreadsheets printed out to him on paper to go say, oh, this is the demand and this is what we have in stock. And then he's got to do some quick calculations, and their hour by hour of their sales change based upon what they have available. And it's all 100% on the fly. I would say that's about as worst case as you can go and still regularly run a facility and go ahead and make money. To Chris and Dave's point both, I think data is exceptionally important on the plant floor, and it will only continue to become important. I've spent years on how can we tie data in from machines and pump it up potentially as far up as the ERP, although that is almost a pipe dream for most organizations that I work with. Most of the time you start to visualize some data for them, and they're like, this is better than it's been for the last 20 years. I don't have to go look at my stack of papers in the morning and then talk about the issue and then put the stack of paper on the other papers and never look at it again. So I would say that that's exceptionally important, especially as we go to optimize, right? So, and Chris and Dave both gave great examples. One thing we didn't necessarily talk about is once you know and can optimize to the X degree of of what you're cutting, you can then go compare to what you've actually sold and you can go reduce your work in progress. You can go reduce your inventory and ideally only make what you have orders for, or as close as you possibly can to that.
Okay, so some very interesting layers there, and I really appreciate the layer that you brought in about the paper as well as the extrusion. I think those two are going to be a great example where nesting is going to be super critical and important as well. So now the follow-up question that I'm going to have for you is going to be your comment related to cuts versus sold. So maybe you want to do a little walkthrough there for listeners to be able to understand, why is the cut that you are doing is different from your sold, and why is there going to be a discrepancy in that? Dave, do you want to do the follow-up?
Why what we're cutting versus what we've sold, and why they should correlate? Is that the question, Sam?
Yeah, I think what I heard or what I understood based on your commentary is there is going to be a discrepancy between what you are cutting versus what you are selling. So I don't know if this is going to be more of the WIP that you are trying to produce and then you are trying to utilize in your finished good that you are trying to sell. And is that the reason why there is a discrepancy?
Well, I guess my comment is more so that once we've collected all the data, right? Once we know how we can go ahead and optimize it, we should be optimizing not just to kind of stock levels or, hey, we can cut these 10 parts out of this piece. We should be optimizing based upon what we've actually sold, right? So once we've collected all the machine data, once we can optimize out, call it our sheet of paper, right? We know all of the different ways, all the different offerings of how we can go kind of build and cut this piece of paper and all of the end outcomes for it. Our goal should not be just to get 99% utilization. Our goal should be we should utilize it as much as possible, but our goal should be utilize what we can sell as opposed to utilizing what we can get to 99% utilization, because our throughput should be what we can sell out the door as opposed to just putting inventory on stock.
Could not agree more. Thank you so much, Dave, for that clarification. So, Andy, I'm actually coming to you. Obviously, you have been, in the nesting space for a while. Chris, do you have a comment?
It's a comment for Dave, and Dave's right. Is the outputs of all this performance data needs to come back in and update the standards so people can reevaluate the pricing and be more successful selling. So that's an iterative loop. I think that's where you were going, Dave. I just thought maybe it sounded like, yes, we need to update, use that data to impact our selling abilities. Not only that, but your production capability. I understood you were doing capacity as well. So that's it.
Absolutely. I think it's all very circular, right? You go and you start to update in one point, and then you should continue to use the data to get better overall as an organization.
Great points, guys. Could not agree more. Andy, so obviously you have spent a lot of time in the metal space as well as in the nesting space. So what has been your experience? Do you agree with these guys so far in the industries that we have discussed? Have you seen this being used in any other industries that we have not discussed so far? And overall, what has been your experience with nesting?
First off, I've never done nesting, but since the kids left, my wife does it all the time. To make it very basic, what nesting is all part of a lean manufacturing environment, because what you're doing is, like Dave mentioned, is eliminating waste. When you have a sheet of anything, and that there's mentioned about leather, paper, sheet metal, anything that has significant value, you want to maximize or optimize the waste, the leftover piece. That blends along with another concept called dimensional inventory, because whatever you have left over on that sheet, you want to be able to inventory it and use it at that dimension on an additional order in the future and make sure you optimize the raw material. Now, obviously, it's very commonly used in the steel industry. Steel is very expensive. So when you have a sheet of steel, the demand is going to be a list of widgets or things by their dimensions. So if you can picture this 4x8 sheet of steel and then placing all these weird looking shaped things, it's like a puzzle. The nesting will basically turn pieces left and right to make sure they're maximizing and having the least amount of space in between each, so the scrap is very much minimized. The challenge with that is very few ERP systems have that. I mean, they're using unit of measures, right? As opposed to, it's really theoretical how many you're going to get out of a sheet of steel. So the challenge of that is interpreting what the output is from the nesting to be able to update the ERP cleanly and have a fairly accurate inventory control. But again, you want to be able to not just nest the products, but then whatever the offcut is left, be able to inventory it and use it in future jobs.
Okay, some great layers there. By the way, I completely agree with your comment. Even in my case, my wife is probably going to be naturally, inbuilt for the nesting process. She does not need any sort of AI.
Doesn't need any software.
Yeah, exactly. Yeah. So great comment there. But the other comment I'm going to have here is going to be related to the dimensional inventory that you mentioned, and I don't know how many companies are really going to be integrated, because this integration obviously could be very complex, because you have a little back and forth, and that back and forth is slightly unpredictable in my mind, the way it works again. Because the kind of pieces you are going to get, that's your BOM may never understand that. So I don't know how you are going to integrate that. So in your experience, Andy, when you are working in these engagements, are they typically integrated, not integrated? How is the handshake working on the real production floor when you are talking to, let's say, your customers?
Well, you know how it is these days, and everybody else I'm sure will agree that anything can integrate with anything as long as you have the APIs and the right data points in between the two products. The challenge is when you're nesting is these parts are commonly unique. You may have never made that exact dimension before. So creating them and then updating your ERP with an increase of those inventory items can be a challenge. And not many systems have that capability set. Although many of them do claim it, I'd love to see it work before I said, yeah, I've seen others do it.
Yeah, exactly. Yeah. Amazing point. Thank you so much, Andy, for that. So, Chris, I'm actually coming back to you, and we are going to be discussing the integration challenge here. Because obviously the integration could be very complex, and most people, I don't know if they realize how complex this nesting integration could be. So let's do a real walkthrough of the BOM.
Sure.
Okay, so let's say if we have a BOM, and what nesting software is trying to do is, as Andy pointed out, that it is actually trying to create all these random weird pieces, and all these random weird pieces are going to be fit in a specific setting. It's not that they are going to be fit for everything. So you need to make sure that they are going to go back to the right BOM. And then you have the pieces left, which is going to be your scrap. That scrap has to go to the right inventory as well. So there is going to be not just the alignment between the BOM that for which you might be producing this WIP, for which you are actually trying to maximize or reduce the waste, but then you also have to worry about the other pieces. Okay, which BOM are they going to go to? And you need to make sure that the data is going to be right, because if you're going to break that, and by the way, there's another layer of unit of measure, because I don't know whether you're going to be measuring this in terms of pieces. If you're going to do that, how are you going to differentiate between these pieces? So I don't know, Chris, any commentary there?
Wow, it's a real interesting challenge if you think about systems integration, because I really think what you're going to see in play today is a lot of siloed applications, and there are some that are close to each other. For example, the machines, and let's just start from the shop floor. These guys have been running their shop floors for a long time. You got the machine level coders, the guys go in there and they key in jobs. Okay, so if you think about so historically, 99.9% of the jobs in those machines were keyed in. Okay, big guys have integration, but to feed in, and you're correct, interpretation of the data from an ERP, it's a BOM, it's a routing. The machine's like, what is this stuff, right? The fields aren't in the ERP, so what is it communicating with? Most logically, CAD applications and PLM systems, right? So if you think about the guys, the architects, the engineers, they're not using the ERP, they're doing all CAD-based work. So the communication in place for probably a while now is CAD to is PLC code and into these machines. So as the machines are still growing up, they're still taking those inputs, meaning for a laser cutter, you're loading job. You're loading multiple jobs, and you're feeding it inputs, and then you say, all right, let's go take a coffee break and see what it comes up with to run for the next 12 hours, for example, based on, demand per piece, and you're loading all the GUI CAD attributes that's interpreted by the applications on these machines. These are a completely different OS, another platform. Again, the logic, intelligence, and algorithms that are in there, they're dimensional-based algorithmic. So, again, ERP data, CAD data, two different animals. Okay, well, I've got CAD to ERP integration, but that CAD to ERP is still BOMs and change management. But if you look at that, that doesn't replace a CAD to a piece of equipment, to a CNC or anything where you're feeding the programming programmatically from the CAD drawings. ERP is never going to speak that same language. So, I would challenge in the one application I'm doing, we got Dynamics 365 Business Central, and the equipment manufacturer built modules for BC. Why? Because there's gaps. BC doesn't know how to talk to that piece of machine. They may be, okay, how am I going to land those inputs? Machine time, worker time, pieces, scrap. Okay, BC may be more likely to accept a few touch points, but to communicate with the machine can't happen. So even to Andy's point, where's that smarts happening? It's not ERP based. Next level over. Is it middleware? Well, again, unless I manually load that piece of equipment, that laser cutter from my CAD, which that's what they're doing today. And there's job numbers, so they get a report. What happened? What do they do with the data? They go type it in or do whatever. But anyway, there's the example. And so that integration's not there. And this one I'm working is okay. And I'm still, let's see it. And I'm trying to understand but the the ERP to the MES is going to be quantitative. That's the order. It's the demand. What am I trying to make? What's my due date? Right? Quantities and stuff, because that's linked back to the sales order. But the MES is talking to the machine, and that machine's got a CAD interaction besides just getting the quantities of production, because the machine's not randomly making pieces. Even in a build to stock, I'm making 1,000. I've got a target quantity, whether it's to build for a customer order, a stock order. So again, there's no randomness in how many pieces the machine's trying to figure out. But quantities, unit, the finished good, what's the part, what's the quantity, when's the due date? That's coming from ERP. CAD is sending dimensional aspects and attributes, and it's marrying it up, and then those machine-based applications are doing a lot of that hard work. Then they're like, okay, I got all this data. Right now, we want to go back the other way. And like I said, it's primitive today. But I think over the next couple of years, we'll see more of these systems show up. Frankly, But
okay, so some very interesting layers there, and I think this is going to be a question pretty much for everybody, where they see sort of the nesting in the process, whether that is going to be part of more of the engineering or that should be part of your production workflow. So here, when I am looking at this workflow, and again, I think the setting may vary as well. For example, when you are working with the engineer to order shops, there you are going to have far more interaction, in your engineering BOM before you are going to be realizing the product. So overall, let's say if we look at the nesting, right? So one comment that you mentioned, Chris, is this is all part of engineering. And typically in my mind...
Well, actually not just engineering, because I came up with a few other applications we didn't talk about, like print jobs, big roll print jobs. Okay, that's a graphics artist that's laying out a block of art. And then there's a die cutter somewhere else that's going to take these massive rolls of print jobs and die cut them. So we didn't talk about printing. We talked about fabric. The other one is steel slitting. Same type of thing. So the levels of engineering are going to vary, and the complexities and the algorithms to... laser cutters is more complex, especially if it's an optimistic one. Slitting, right, that's a little different. Some of the fabric, so again, we're going to go up in degrees of complexity. Not to interrupt you, but it's not always engineers. Good at the artists.
Okay, amazing points there. Thank you so much, Chris, for that. So Dave, I'm actually coming to you, and I'm going to have the same question for you as well. Where do you see the place for nesting? Is it always going to be, let's say, in between your engineering and ERP, or is it going to be part of your production process? Because if it is going to be part of your production process, then obviously you are looking for far more collaboration in terms of data, if it is going to be as part of your engineering process. So that is going to be right before your product realization. So any sort of variability that you're going to have in your product and BOM, that happens before your engineering, and you can feed this engineering data to your nesting software. Nesting software is going to give you, okay, this is the real BOM. Your assumption is probably going to be that, once it goes to production, that assumption is probably not going to change. In some industries, I can see that assumption may change as well, because whatever you are doing during the engineering, production may say something else. So in your opinion, where do you see the whole nesting process sitting? Is it, in between engineering and production, or do you see it more as part of the production process?
So, and I don't know if this counts as playing devil's advocate or not, but I really see it living more on the engineering side. Now, I think perfect world, if we sit down and say, rainbows and unicorns and all these kind of jargon things we talk about with the industry and where it's heading Industry 4.0 and all that. Perfect world, all of these are aligned, and the ERP system talks to the CAD system, and you've got it feeding to, Chris, you were mentioning, feeding into the PLC, and everything's living in harmony. But as we talk kind of real nuts and bolts, I think the nesting piece of it really is going to continue to kind of live more on the engineering side, and I challenge you to find an engineer or a graphic artist that cares what's happening on the ERP side whatsoever. If you can get them to log into the ERP, I'll give you $100 for that, because it is a different job function, and I think people challenges aside, technology challenges aside, I think even probably within next 5-10 years, we're not going to see that change significantly, in that this sort of the nesting process and understanding exactly how we're building something is going to continue to kind of live outside of the ERP. Now, the more we can get those touch points like Chris was mentioning, so if we can know how much we actually consumed, what our scrap was, those are the things that are going to be important. But we in the past even worked with like an aerospace type of manufacturer, and they had in the ERP system, they literally called it the ERP bomb, because it really didn't have anything to do with how you actually make this in real life, because that lived in engineering, and it was strictly for accounting purposes and basic production planning purposes. So there's still that divide between the ERP production and engineering, and that's not necessarily what you want, but frankly that's the reality in a lot of organizations today. I think we'll see that change as technology evolves, but in my opinion at least, this is not a process that we're going to see smoothly integrated into the ERP anytime soon.
Okay, so some very interesting layers there. And by the way, since you started the trend of, devil's advocate, I'm probably going to continue that, and hopefully Dave and Andy can follow up as well. So on that note, I can see some value where Chris was going overall, having this as part of the production process in some of the industries. And this is the question which just blows my mind. Okay, so if I talk to some of the companies and I ask them, okay, what's your product? Mm-hmm. And you know what the answer is going to be? You don't have a product. Just don't have a product. Okay?
Yeah, all right.
So, for example, let's say if you go to any of the print shops, any of the engineer to order that are going to be super deep into engineering. You go to apparel shops, okay? Some of the apparel shops are so custom. Every single dress that they are going to produce is going to be custom. That's their secret sauce. That's their business model. Now, if you look at the planner or the guy who is responsible for nesting, typically the way they work is, and sometimes this could be a real process issue, and it's very, very, very hard to coach somebody who has never seen that this could be part of engineering. For example, Let's say if I'm talking to, I've seen some automotive part makers, cutting tools, the way they approach this is, okay, as soon as you are going to get the BOM, then they are going to figure out, okay, how am I cutting this? Then they are going to figure out, okay, how am I allocating this? So there is a little ad hoc arrangement there. And sometimes for them, if you tell them that, this is more of a rework process, or this is a different BOM, they just don't understand that. So I don't know. See, there is a little value there in the engineering to order scenario where each job is going to be custom, but I can see that as more of the process issue as well. So Dave, Dozer, I don't know if you're going to have any sort of follow-up comment.
Yeah, I kind of share the same sentiment. There's value there, but it's again, when you're talking these job shop type of things, it's very challenging then to always get that to align, because it's different every time. So you're kind of figuring it out, so to speak, each time. So to automate that or align that becomes just a huge challenge, and that's something you're not necessarily going to solve even with software in some cases. It goes back to process, really.
Yeah, could not agree more. Great points, Dave. So Dave Griffith, I am coming to you, and I am going to be asking your perspective. Where do you see the nesting process? Do you see that as part of the engineering production shop floor? Where does that belong? And if you have any sort of follow-up comments on the commentary so far.
Absolutely. So first, Tim, I'm going to say, being the process guy, that if you guys as ERP folks are struggling to get basic system information like cycle times and what is scrap and what is not scrap, you should call me. If I can't help you, I'm sure I can find someone who can help you, because we've solved those problems 10 years ago, right? We solved those problems 10 years ago. That should not be what holds us back. And secondly, Sam, I think I finally get to answer the question how you've been wanting me to answer a question since the first time I've been on here. The answer is the MES, right? But I guess in my experience, I would say that if we are doing optimizations, if we're going through kind of this nesting process, it belongs somewhere between production and engineering and scheduling. In my, probably super biased opinion, that is somewhere below the ERP when we look at the tree. To Chris's point, like, we can certainly push that information up. We can certainly pull that information down. To the CAD comments, we can probably pull in the CAD information via API to both the ERP and to the MES, and we know that the CAD software or whatever's holding our drawings is the source of truth. And if we've integrated it correctly to both systems, we know that it's working correctly on both sides. Re-engineering versus production, I would say that, I guess, in my opinion, it really goes to the question of how much of the same are we doing? Are we running generally the same set of homogeneous parts? If we are, engineering doesn't need to be involved in it nearly as much. If we are to the part of we are every week running 50% brand new items, or I guess, so I worked with a client who basically ran everything once, right? So they ran everything once. Best case scenario, we took the learnings from the things that they ran once, and then almost every time their clients tweaked it for the next run, right? So we'd run 100 of something or 1,000 of something, and then it would be done. We'd hopefully take some learnings, and then we'd use it for whatever the next run of that would be. So when you look at that, that's very much going to be in the engineers or the artist side of things. Like, how are we going to do this best? And then I would say, to kind of Andy's point, it gets much harder if we're looking to cut something out of like a plate of steel, and then we're going to put whatever's left back on the shelf, and then we're going to try to hopefully remember to reuse it, right? It becomes much easier if we're going to run through an entire sheet of plate steel, or we're going to run through an entire ream of paper, than it does if we're going to do something, pull it off, go put it back on the shelf, hopefully remember to scan the correct one in when we need to use it next. And then that becomes an accounting nightmare as well, which was like, I was getting cold sweats as we were talking about it, Sam, thinking of how are we going to account for this? And then what sort of overruns are we going to have? And then how do you take those overruns and displace them or put them across the number of assumed runs we're going to have over that piece? So I would say that I don't know, if you can make the nesting that you do within your organization, if you can set a minimum quantity of that and be able to run through, that's going to make your life easier. In the real world, most clients do a lot of job shop stuff, right? So they run a number or a bunch of one-offs, and then that is where they have, huge market opportunity when we talk about that.
Okay, so some very interesting layers here, and we are going to be seeking everybody's opinion, how comfortable they feel that if this responsibility should reside inside MES. But I am actually going to be a little curious there in the architecture. So MES, in my mind, the way I think of MES, it's further downstream. So you have engineering, your product is realized, that goes to your ERP, and then when you are going to go to real production phase, that's where MES is going to be in play in the architecture. So now let's say one architecture or, that we can draw here is, so since you mentioned that, shop floor, anything happens on the shop floor, happens inside MES, great. I get it. That, so let's say I am going to tell you that, okay, I am trying to produce these 500 jobs. Now you shop floor guy, you do whatever you want with these 500 jobs. You can cut in the dimension that you like. You can utilize the material the way you like. Okay, and once you are done, just tell me, what was your sort of the context, which is going to be more from the accounting perspective. So I can go ahead and close my job as the accounting guy. Okay, the challenge in this architecture that you're going to get is, okay, so your assumption is going to be these 500 jobs that you are trying to manufacture or produce on the shop floor. Your assumption is going to be whatever material that you are trying to consume, you don't have anything left out that is going to be used by some other jobs. If you are going to have that left out material, okay, what do you do with that? Are you going to report that back to your ERP, and then ERP sort of figures out, okay, where do I put it and which mom is going to be the right fit? So then you go back to your ERP. So do you want to do a little walkthrough in terms of how you see this working, Dave?
Absolutely. So I would say that I think that's a very good point, Sam. And when I kind of made my point that it should live in the MES. I guess my point is it should live more on the shop floor side of things below the ERP, because again, scheduling is going to be very important, right? So like let's say we've got 500 jobs. We would only be setting ourselves up for failure if we were to send all 500 jobs out onto the shop floor to say, go ahead and run whatever you're going to run. Most facilities that I've been to, we are going to schedule them right, wrong, or indifferent. We had a long scheduling discussion a few weeks ago, but you were going to schedule them right, wrong, or indifferent, and there should be kind of a stream of these are the jobs that should go in. And that is where we kind of, depending upon what we're running, we may have to loop in engineering to understand what the optimization of that nesting process looks like. So my point is more so that we're going to have orders that are going to come in. We're going to have raw materials. We're going to have due dates, right? That needs to go get scheduled. And then based upon what the schedule is going to be, it needs to go get pushed out, onto the shop floor, depending upon availability and all of the other factors and criteria. I guess I personally have never seen being able to scheduleize and optimize a nesting process, or honestly a ton of other processes in my manufacturing experience, exceptionally well in the ERP. To Dave and Chris's point, I've seen lots of fake bombs, right? I've gone and looked at a whole bunch of fake bombs, and you go drill 3 levels deep and it's like screws, right? Or it's like sheet metal, and it doesn't give you all of the information. With that, you very much have to kind of pull in all of that engineering information. And it goes back to my comment of, hey, is this going to be a homogeneous run, right? So are we running a whole bunch of the same thing because that's easier, and we're going to run 1,000 or 100,000 of the same series of parts, and we can just run those for X number of days? Or are we going to go through the process, and we're going to run each of those 500, they're going to be 20 parts each, and we've got to go do that engineering. We've got to go pull in those designers and those artists to understand how everything is going to fit and how we can make the cuts successfully.
Okay, amazing insights there. Thank you so much, Dave, for that. So, Andy, I'm actually coming to you, and obviously there's a lot of different layers here, and the group seems to be divided in terms of where the nesting should live. And the space that you live in my experience, when you are looking at these smaller packages, typically they sort of, try to combine everything in one package because it's just easier. Then you don't have to decide, okay, where it should live. Okay, so you have the engineering, your production, as well as your shop floor as part of one package. So in your experience, Andy, what do you think? I mean, where should nesting live in the architecture?
Well, the answer is it depends, because every company is unique. Every process is unique. Every expectation of the end result is unique, and depending upon what type of manufacturer and what their purpose of nesting is all about and how they want to be able to track it after it's produced, it could be on the manufacturing side, it could be on the engineering side. But I'll tell you another area where it's really interesting with nesting is costing, because if you think about weird shapes, how do you decide what the cost of that part is? Now, I've seen some companies, like let's say it's circular or whatever else, they just do an imaginary box around it and use that dimension for the cost. Others use that circle piece, weigh it, and then cost it by weight. But again, it's completely theoretical, and it's a major challenge. As I said before, there are some ERPs that claim to integrate to these nesting products. The problem is the word integration is a euphemism. Everybody has a different interpretation of what that means. And so if you're looking for a nesting product, or if you really do want to integrate a nesting product to an ERP, I recommend you document exactly what your expectations are, and then ask to speak to companies that are already doing that with those products and confirm it's real.
Yeah, so some very interesting insights there. And by the way, great point about costing. And by the way, I'm going to add another layer that Dave had mentioned about scheduling. So when people think of scheduling, they are only thinking about the schedule. Okay, scheduling is typically way more than just the schedule itself. Typically, you are looking at procurement as well. Okay, so let's say if we hand off this responsibility, okay, MES, you go and do everything that you need to do to produce the job, and then come back and report to me whatever you have to. So now we are looking at the costing data. How are you going to get that costing data from MES? That is number one. Number two is going to be, okay, even if you are handing off this responsibility to your MES, how are you going to be doing the scheduling? Because You need to get the parts right. So now, are we moving the procurement inside MES as well? So Andy, do you have any sort of follow-up comments there by any chance?
You mean regarding scheduling, taking nesting into consideration?
In this architecture, do you see any concerns? Do you see any positives? Any commentary?
Well, because once you do the nesting, the output is known. But until you do the nesting, you don't know how many parts you're going to get on that sheet. So the costing, the planning, knowing how much raw material you're going to need, knowing how much labor you're going to need and machine time, it's really theoretical. And I'll bet a lot of companies are using previous experience to be able to estimate that and justify that, as opposed to the systems.
Yep, great points. So we are going to do one more follow-up round in terms of comments over comments. Chris, any comments so far? Do we have any agreement where it should live? I don't think so. Everybody sort of.
It's interesting, and I drew a little diagram with engineering, ERP, MES, and I think there's one from engineering to MES that goes around ERP, frankly, and MES talks to the platform products. But I think today some of those links are broken. So, but I absolutely think that, and even if, and again, this project, I'm dying to see what they've done. I'm like, give me code, give me a demo environment, because to your point, Andy, is like, what touch points, right? We assume that, hey, you're gonna have the actual. What do we got? We got the material for the size, the dimensions of the piece. How many pieces did you make? We've got we have a standard material on our BOM. We're going to get an actual material issue, and we'll get a variance. Okay, and then but we've got a scrap allocation that's in there. So don't forget that. And again, you're right. Are we catching machine time? And we got a cost per cycle for machine, and you're right, but those are those inputs that I'm looking for. But it's external. To the point is, our core stuff doesn't have that level of control that communicates to the machines. And I still think that even if that middle MES system, it is right, because the algorithm's going to tell you we need to get all this done. Okay, figure out how to fill sheets and how many do I need, and right, and something's quantitatively doing that behind the scenes, not a human, because they're not going to be as efficient as an AI algorithm in today's platform. But to Andy's point, and then you're right, the data is all actual. So again, even as you cost, and if you're standard costing, you're going to see real usage, real scrap. You'll see efficiencies, and again, what are your goals is to do better and better. But a lot of inputs, and again, a lot of manual data points. And one challenge I would put is, you think about people that capture that data today manually and use it. Right? Do they go in there and try to code it to look at costing? May not be the whole universe of what they make, but even to take one example and try to capture the actual data, machine time, pieces, scrap. Is there a place in your ERP to key those in? Well, that's the first thing in understanding whether you can capture some of the benefits of this nesting data, because it's going to give you the report. You got to key it in. If you don't key it in, what's that mean? That you're costing your equipment on a macro basis, right? That means you book cost, you book usage, you look at the P&L. Hey, I absorbed 99.7%. That's enough. But again, the amount of data that you're going to get lets you refine that, lets you improve your pricing. And I think the challenge for organizations going forward is got to be more efficient, because you can't be competitive, because the guys that are on the other side of the Pacific are going to kill U.S. manufacturers in terms of efficiency. So that's why there's still time for people to take advantage of this technology. But again, there's a lot to it, in my opinion. So.
Okay, amazing, great comments, Chris. There, Dave, those are any comments?
So I will double down on Andy's comment there around integration and the subjectiveness of integration in general. And this is definitely one of those areas in all the spots, because when you're talking about the CAD and the MES and the ERP and all of those talking, if you asked all four of us here, we'd even give you different answers about what the integration between those looks like. So that's obviously the most important point. And one of the themes, I think, probably for folks that have watched the whole episode today, I think this is really one of those areas where it's conditional in the sense too of when you're talking about how to apply this in your business, and we talk about the integrations and who owns it. I'm going to stick by my comment that it's really kind of lives over on the engineering side. But at the end of the day, every business is different. It's going to be unique, and it comes down to that process being appropriate for what your business looks like, and then doing the best you can to align that with the systems that you have, or in some cases don't have, and leveraging that to get the appropriate costing, knowing what you're using, and allowing you to get product out the door. And at the end of the day, that's what really, really matters the most.
Okay, amazing. Thank you so much, Dave, for that. Dave Griffith, any comment or comments?
Absolutely. So I'd like to, I guess, triple down now on everyone's comment with integration, and to Andy's original point. The only way you're going to be successful with an integration is if you know what you want, right? So if you were to tell the 5 of us that you wanted an integration, maybe it comes up with 4 or 5 different things as to what it would be. And my immediate answer is, what do you want? The answer is, we can push any information from the plant floor into the ERP in basically any format that you want. But what do you want? And my honest to God hope, Sam, is you don't say everything, because if you say everything, it means you've got no idea what you want, right? You've got no idea what you want, and that's going to set us down a path of frustration. But before you go through the nesting processes, come up with a list of things that you're hoping to get. If you guys have rules that you schedule and optimize by currently, those sets of rules are going to be exceptionally helpful as you go to compare platforms or where you want to put it in general. But if you go in saying, hey, I want to go optimize or go nest my process, you could talk to a dozen different groups. They're all going to come up with a dozen different answers, and none of them are probably going to be the best for your specific situation.
Yeah, great points. Thank you so much, Dave, for that. Andy, any comments over comments? So
Well, yeah, only the fact that if David's going to double down and David G is going to triple down, that I'm going to quadruple down, because if you put $1 down on a 32 in Las Vegas and quadruple down enough times, you're a millionaire. So, I hear about this integration concept in so many aspects when it comes to ERP, and we all know there's so many data points, thousands. And I hear about these certain products that say they integrate to nesting. All I'm going to say is, I don't know what that means, right? And you need to know what that means before you invest in those products, or else have that integration as part of your plan. So as opposed to reading the marketing materials, I recommend you speak to companies that are actually doing it.
Okay, amazing. Thank you so much, Andy, for that. So the only thing we can take right now is going to be closing advice. Chris, any closing advice? You're on mute. Now,
look at your processes today. Look at how you're capturing the data. Look at your costing data. So again, in advance of having full integration, there's still a lot of data that can come out of those platforms. But certainly if you're in that industry, you need to look at how to optimize your utilization of materials and processes and get to that efficiency. Whether it's fully integrated, crawl, walk, run. If you're 100 a million, you got the volume, you have to be integrated. If you're running smaller volumes, you get it. So just do an ROI on it.
Okay, amazing. Thank you so much, Chris, for that. Dave, those are closing advice, please.
Yeah, do what works for your business. And this is definitely one of those areas that, there's other spaces where I'll really hammer home, like, you need all your systems talking to one another. This isn't one of them. Focus on what works for your business, and roll with that as long as your business processes are sound.
Okay, amazing. Thank you so much, Dave, for that. Dave Griffith, closing advice, please.
Absolutely. Figure out what's currently working for you. If it's currently working, don't upset the apple cart, if you will. Do something, find something that works for you, that works for your business. And my other comment is, try to get off of paper as quickly as possible. Even if you're dumping it in any system, the data, then at least you have the information moving forward, as opposed to a bunch of pieces of paper no one is ever going to look at.
Great advice. Thank you so much, Dave, for that. Andy, closing advice, please.
The value of an ERP is measurable. The value of a nesting software is measurable. I'm not sure if the integration and the value of that is measurable. So what I would recommend is do what you need to do. Get the nesting software, optimizing your raw materials. And then, hey, if someone can prove to you the integration has value and has an ROI, wonderful. But if they can't, I wouldn't touch it.
Okay, thank you so much, Andy, for that advice. So that's it for today. If you joined for the first time, this was part of our digital transformation series, for which we meet every Thursday at 5:30 p.m. Eastern. we pick one topic related to digital transformation, and we always have an expert panel here. So make sure you guys are going to be here next week. We are going to come back with another topic. On that note, thanks everyone for your time and insight tonight.
Good seeing you guys.
All right. Take care. All right. We'll see
Thank you, everyone.
Bye.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Chris Garadini, head over to turnkeytech.com. CURNKEYTEC.com. If you want to learn more about Andy Pratico, head over to essoft.com. It's ESSOFT.com. If you want to learn more about David Dozer, head over to blazeiTweb.com. It's BLAZEITWEB.com. If you want to learn more about Dave Griffith, head over to dave-griffith.com. It's DAVE-GRIFFITH.com. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Ira Sharp, who shares his insights on open automation and why that is important for manufacturers to understand as they increase the Industry 4.0 maturity of their companies. Also, the interview with Jason Anderson, who shares his insights into edge technologies and how manufacturers and field service companies can take advantage of them. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to get you on the next episode of the WBS.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.